Hello everyone, welcome to the channel and welcome to my workbench. On the agenda for today is modifying the height of this Ikea Strandmon Footstool to match an existing sofa. I'm going to use 3D printing to achieve that, and I hope that you will join me on the journey. In this picture, we can see how things are supposed to be. The Strandmon Footstool is a horizontal extension of its matching chair with its top surface in the same plane as the top of the seat cushion. Since the stool has been bought to go with an unrelated sofa, the heights have turned out to be slightly mismatched, and anyone using the two together finds that their legs are slightly elevated, which is not the most comfortable situation to be in. To solve this problem, we are going to have to reduce the length of the legs one way or another. We have two options for shortening the legs. Either we can take the ones we have now and cut them down, in which case I will have these manual tools to use, and 3D printing might offer us a way to jig them for an accurate cut. Or we can fabricate entirely new legs that mimic the existing geometry, and in that case 3D printing really seems ideal. Okay, let's bring out one of the existing legs and have a think about what we want to do with it. So here we are back in the workshop, and having taken a look at the leg, it does seem like a shame to me to cut it down, when what we could do is save this off to one side and have it to come back to. So I've come up with a plan to 3D print a short leg. The other advantage of 3D printing is that rather than cutting off this end and leaving a fat stub, we can effectively cut off this part, the fatter part. So I've found this nut that slides on here. And looking at this construction, we basically need to make this body. We need an equivalent of the soft tab to avoid scratching surfaces. And I think we can do better. I think we can do better than this little bit of fluff, which looks like it could easily peel off. You can actually absorb some impact. So we need this body and we need a bolt to attach. So here's a nut from my collection, and here's some bolts that I have available. So we need to choose a bolt. I've measured this to be M8, so here are some M8s. And we need to then build the body for a certain bolt to fit. Now, the big test is which of these bolts, some of which are recovered from Ikea furniture, is compatible with the bolt that's going to be on the footstool body. And these ones would have been good. They're recovered. I think one of these is from a bed and one of these is from something else from Ikea. These pieces are recovered from a non-Ikea piece of furniture, and the bolt does thread on this one. But this is a slightly odd item. The back end comes off as well. Not sure. So anyway, it's a possibility. From the same sofa I actually recovered this from when it was being destroyed to be sent to landfill. I also ripped out this, which has this great spike at the end, and I don't think I want to design around that. The possible advantage of these is that we could introduce the bolt into a thread from above, and then the printed leg would be mostly solid. Just this. penetration from above, and then the entire bottom part would be solid plastic, or as solid as we wanted to make it. My last option is just a regular M8 bolt, not recovered from furniture, but a new bolt. And this is compatible. But thinking how we would print the new leg to come in from this side, we would have to penetrate a hexagonal profile through and then have some to get the bolt in, and then the bolt is sucking the leg against the item. So to stop the bolt coming out, it would then have to sort of latch into something against the direction of travel. It's complicated. So other way to come in is from this end. So coming from this end all the way through and stick out through again a small hole. So then we have a hexagonal pocket this way. This doesn't look like there's much space if we start from here. If you think about all the weight of the footstool bearing down around this thin ring around the edge, left by around the edges of the pocket. So we have to be confident that that will bear the weight of the footstool. Now, when a foot's on a footstool, it's not the maximum load. The maximum load is taking a quarter of the weight of a human being who is sitting on the footstool. So can one human being's worth of weight divided by 4 be borne through a 3D printed part that ends like that? Not sure. Or we could be buried, like come in, buried, and then fill up that gap. But to fill the gap between the top of this and this surface, we would need to be very accurate in our measurements. If we're like a millimeter out, now the central part, the central hexagon would bear the weight. If we're a millimeter in, the central hexagon would bear none of the weight. So it's putting a lot of stress on our measurements, but it's an approach we could take. I'm going to play around with the in from this side options and in from this side options in CAD. I think having this bolt screwing from the top, one, it seems simplest. It's putting a lot of pressure on the accuracy of the threading on my 3D printer, which I don't have much experience with pushing, so I don't know if that will work. So if this one will make sense, I think I will use this one. Yeah. Anyway, let's go to CAD. So here we are in FreeCAD, and I can show you what I've come up with. I've got a leg, I've got a foot for the leg, which is to be printed in TPU. And I've got these other 3 parts, which were an experiment with making a mold for spitting out feet like this in a soft resin. Let's have a look at the leg. The bolt will exit from this hole, and it will enter through the bottom here. As a small detail, I have made these features in the corners so that the sharp corner of a bolt won't interfere with the slightly rounded effect that you get when the printer head tries to change direction suddenly. Another feature that we have is a little lip here to catch the foot so that it doesn't shift from side to side. Concentrating on the leg now, I can show you one slightly interesting feature. If I go to transparency, now we can see inside the body there are lots of these vertical structures. If we look around it, we can see them stretching from top to bottom. I'll maybe have a look over here with the clipping plane so you can see a little bit more inside. The point of these, the way these function, is to create infinitesimal voids inside the part. And the effect on the slicer is for it to generate a wall around each one of these. Since we have the load from the person sitting on the stool directed in this direction and then transferring out to the floor here, we want that load to be carried by a contiguous structure, not by crisscrossing infill in this interior space. These walls that are built around these slices become these towers of filament, and then we can effectively have very low infill around them just to hold the shape. But the loads are born through these continuous structures inside. If we take a look at it in the slicing software, we can see that the voids that we created have indeed generated these towers of plastic. So now all the way from the bottom to the top, we have a tower of plastic bearing the weight. Later, during the printing process, you can see that the same towers of plastic are being built up around those voids. The TPU plug is fairly straightforward. We're only interested in it for its geometry. It plugs into the leg. It will be printed on this face, which will be down on the plate to give a nice texture. It's a slight chamfer. These ridges along the sides, they will serve to grip on the inside of the leg, and will rely on the flexibility of the material to let it still enter the gap. This surface here will touch against the top of the hex bolt and will hopefully transfer the load from the hex through to the floor. So after all the printing is said and done, this is the result we have. We have a shorter stool leg. The features include TPU foot and the embedded bolt, which is fairly secure. There's a slight back and forth rattle which will stabilize once the thing is screwed into the footstool. And we've come in from the top and we've plugged the gap with the TPU foot. And comparing to the original, it was substantially shorter. And we match at a narrow end rather than at the chunky end. So there we go. Here on the chunky end, there's a vast difference. On this profile, you see the feature mentioned in the CAD where the corners are excavated. That means that we get from the bolt very nice fit. Sure, that is just passing in. And we don't have these sharp corners binding up against rounded corners in the pocket. So assemble by extrusion from the top through. Pretty stiff. It's not going anywhere, that one actually. Some of the others are less stiff. And then from above, you see we have a lip here of 1 millimeter high and 1 millimeter wide. That means that this TPU will be captured, not want to shift left and right. Yeah, it's quite difficult to get the TPU in. Looks pretty good already, but it can probably go in another 0.5 mil, and then that bolt is captured. So it can't go that way. Since the head of the bolt is touching the TPU, it gives me some confidence that the weight bearing down be transferred into the top of the TPU to some extent, and it won't all be borne around the edge. So putting that one aside, looking a bit more carefully at one of these, see the feature of ridges that grip the sides of the pocket in the foot. But yeah, you've got a nice structure, got the rounded sides, rounded chamfered top, lets it slide in. We have the slight chamfer on this top edge that lets it fit neatly into the tops of the part. And the texture from the bed actually looks quite nice on the bottom, I think. So yeah, we just have 2 more bolts to go in and 2 more of these to go in. The other thing I experimented was the mold. I was going to pour some soft resin into a mold. So I had a 2-part mold prepared. This is basically the negative of this in there. And then this part is just a funnel. So the resin makes its way in. I hit it with a few coats of primer because I didn't want to be sanding and priming and sanding and priming, but I hit a few coats of primer and then some varnish on top of the primer. But then that turned this into a very stiff fit and it got stuck. This is very brittle, weak PLA that I was trying to use up, which was possibly a mistake. But in theory, it would have been a 2-part mold. That would have sat there, this inside, pour in the resin, let it set, and then pull out and use this part here to push out. Which, if I made this better and finish this off, would be the approach you might want to take for small volume production. But for what I'm doing, these were just a few minutes, these prints. So yeah, it made no sense to actually pour any resin and start the timer on that resin aging. The other thing I did do as well was I experimented with a solid bottom approach. So this means the bolt is introduced from the top. Yeah, goes in from here, not in from here as in the others. The hexagonal shaft goes to a certain distance, and then there's another hexagonal section about the size of the head of the bolt in here, which is twisted slightly. So when you turn in the direction that you're going to screw, this now gets trapped in there and it can't come out. And then I modeled another hexagonal on the outside, round on the inside section of plastic that just stops this wobbling around. It's all a bit more complicated and not very satisfying. And I should be able to just twist this and pull this back out, and it's not happening. So something's gone wrong. Anyway, this was rejected, and that's so I was printed in junk white plastic. Anyway, let's go back to the finished ones and get them screwed in. So yeah, so this is what I have. I'll put these together, take them to the footstool, and see if it all goes together in the end. So pretty sure that's not going to go anywhere in normal use. And then thinking about its interaction with surfaces, it can be at a slight angle and the soft rubber hits. It's quite far over before. Yeah, soft, hard, soft. So it has to be quite far over before it's the hard plastic that impacts first. Yeah, so this is the moment of truth. That's nicely tight.
I'm very impressed, actually.
Yeah,
Yeah.
comfy,
Sorry?
comfy.
Yeah, it is actually.
Oh, good, good, good. So that seems to have been a successful project with a happy customer. I'll keep asking for feedback and maybe I'll reprint in a better material than PLA. Maybe drop the height even lower. Maybe sand and paint the legs to give a more finished look, though they do tend to hide in the shadows down there. For now, though, they are good enough for the job of raising legs without elevating them, and that is good enough for me. If you want to do this for yourself, links to the files can be found in the description alongside the bolts I used, should you want to be sure of matching my leg and Ikea's stool's nut. How would you have approached this problem? Would you have just sawn the legs down, stuck a fresh felt pad on, and been done with it? Let me know down below in the comments. If you like this video, that's the kind of thing this channel is for. So please do subscribe to get future practical solutions to everyday problems with 3D printing. There may also be a link to another video appearing somewhere on the screen, so please do click that if there is, because YouTube apparently cares a lot about how sticky new channels are when they are just getting started. If you decide to subscribe, I'll be very happy to have you back for future videos on the channel.